Okay, so we've got dy dx equals to x square root of 1 minus y squared, and we're going to separate the variables again. So there's no terms here in front of the dy dx, so it's just 1. And because we've got this root of 1 minus y squared as one sort of package on top, times in by the x, you take it over and divide, okay? So we've got 1 here, and you're going to take that over there, so we've got the y terms onto the left-hand side with respect to y, and we'll leave the x there, but bring the dx over, okay? So we then got to integrate this, okay, 1 over square root of 1 minus y squared. So again, you refer to the formula booklet, okay? And in the formula booklet, on page 7, we've got this result. We've got the integral of 1 over the root of a squared minus x squared equals to sine to the minus 1 of x over a, okay? Now, that's no different to what I've got here, in that a is going to be 1, and the x, you're going to replace the x with y, okay? So I can rewrite this as sine to the minus 1, okay, of y over a, and a is 1. Okay, so that's the integral of that there, using the result from page 7 in the formula booklet, okay, where a is just 1, okay, and then of course the x becomes y. Integrate x, you get x squared raised to the power by 1, so x squared divided by 2 plus your c, okay? So that just then becomes sine to the minus y, 1 of y equals x squared over 2 plus c. Put the boundary conditions in, so when x is 0, y is equal to 1. So sine to the minus 1 of 1 equals to 0 squared over 2, which is 0 plus c. So c is just going to be whatever that is. So let's get my calculator. Sine to the minus 1 of 1. And of course, that's going to be, remember now in radian mode, it has to be in radian mode because we're dealing with integration. So you get half pi, or you write that as pi over 2. Okay? So therefore, sine to the minus 1 of y, okay, just write it as y, equals to x squared upon 2 plus pi over 2. Okay, now because we're halving both of these terms here, we could actually write that as a single fraction, where we got x squared plus pi all over 2. And then remember, to get y equals, because it's sine to the minus 1, take it over and do sine of all of it. Okay, so you're undoing the inverse operation, take it over, so it'll be x squared plus pi over 2. And there's your answer, y equals sine x squared plus pi over 2.